Hello students, hello viewers. In this video we are going to demonstrate one more hydraulic circuit and relay circuit using FluidSim demo simulation software so that you can practice more at home or at the institution. Today I'll take up the second exercise. The assignment second experiment is right. So that is signal storage circuit. So this is a signal storage by electrical self-locking. So electrical latching concept is used here. So relay, one of the advantage of using relay is also like signal storage. Okay. So let me open the software first. So this is a hydraulic circuit and this is a relay circuit. So hydraulic circuit compared to first experiment is almost same, but there is a one change is there. Instead of throttle check valve, there is a throttle valve is there, and in electrical circuit there is a change. So earlier there was only two electrical lines were there, but now there is one more additional, that is three electrical lines are there. Let us see. So go to the FluidSim demo software, double click on it, so run. Okay, it's connecting. Let me check the internet. Yeah, it's opened. Now go to the new file, take a new sheet. So here first list the components required in this experiment. That is, one cylinder is required, double acting cylinder, single rod. Then one pressure relief valve is required, one pressure gauge is required, and 4x2 single solenoid spring return direction control is required, and then throttle valve is required. Okay, and so let me connect the hydraulic circuit. So go to the hydraulic library, click on the hydraulics. In the actuator you can find it double acting cylinder. See, there are two types of double acting cylinders. See, both are same, but there is one change. So this is a double acting cylinder but without cushioning, but this is a double acting cylinder with end cushioning. So that we can discuss later. So in this circuit we have taken one double acting cylinder, and what I'll do is right click on the component and rotate or mirror it horizontally, because I wanted rod chamber in the left hand side to me. Okay, now what to take is, so in the supply elements you can take one sorry, not this one. Let me take first 4x2 direction control valve, solenoid operated. First valve, it is as per the requirement, and pump, and go to the supply elements, tank. So one more tank is required. Since it is a fixed displacement pump, protection is required against the overpressure. So we have to use pressure relief valve. Go to pressure control valve. The first valve is pressure relief valve, and then connect it here, and then one more tank is required in here. It's the tank, and then so this completes the production circuit. And very important thing is, we should have measuring instrument, that is pressure gauge. Pressure gauge should not be forgotten. That's a very important, because what is the pressure in the line should be known. Sometimes when you are dismantling the circuit, it's very important to read the pressure gauge readings. Okay, so pressure gauge is connected, so I'm doing as per the diagram here. So one of the P line is connected to pump line, is connected to pressure relief valve, and pressure relief valve tank port is connected to tank, and there is a tank tank port of direction control valve should be connected to tank line, and AB is connected to cylinder, but there is one throttle valve is there in the line B. So throttle valve is available in flow control valve. Its flow throttle valve is there. So in the line B I'll add it, and B is connected to piston chamber, and A is connected to rod chamber. Okay. Why A is connected to rod chamber? Because initially we want the retraction of the cylinder. If you reverse this, if you change this connection, then without your command, cylinder will make a movement, that is extension. So if you want that, then we can interchange it. Otherwise, as per the circuit, it is A is connected to rod chamber. So I'll name this solenoid as Y1. Okay, so this is the hydraulic circuit part. Next is the electrical circuit. Electrical circuit, I'll take IEC standard, and there the power supply is 24 volts, because operating voltage of the solenoid in the laboratory is 24 volts. Okay, and in switches, you go to the manually operated switches. So go to the assignment here. Hydraulic circuit is completed. The electrical circuit, there is S1 switch is there connected to K1 coil, and so let me correct. S2 switch is normally closed, because S2 is for switch off the relay. S1 is for switch on the relay. It's like set and reset instruction. Once S1 is operated, K1 will be continuously on, coil is continuously on. So contacts belonging to K1 coil will become closed if it is open. So since we are using both open contacts, so it will be closed when relay K1 is on. Okay, so let us draw this electrical circuit. So I'll take S1 switch, general switches. Okay, this is a push button, manually operated switches, and this is S1. If you want to name it, double click on the switch, then in the description you can type S1 and then make a display. Okay. And then we have to take the relay here, relay. So and double click on it. In the identification you type K1 and then make a display. So there's a K1. Double click. I want capital K1. So yeah, capital letters. So now S1 is connected to K1. So line 1 is completed. So line 2 is a parallel line. It is like auxiliary path where it can supply the power without S1 being operated continuously. Okay, so there normally open contact that is available in general switches, normally open contact. Okay, and then normally close push button, normally close push button, that is the third option. You should take that, and that should be assigned, that should be connected before A1, before A1, and this is connected to 24 volts. Okay, and this should be named, this should be linked to K1 relay coil. Double click on it and then link it to link it to K1. Okay, and this one I'll name it as S2. This one name it as S1 and S2. Right, S2 is normally closed, S1 is normally open switch. And now as per the circuit, the line 3, that is switching on the solenoid. Right, so what I can do is I can copy this K1 here, and then you take a solenoid, go above here. The first component is solenoid. This is solenoid, and connect it here and double click on the solenoid. You have to name it. Identification is Y1, and this solenoid name and this here solenoid name should be same, otherwise this will not work. So 3 lines I've done. So this is hydraulic circuit, this is electrical circuit, and now hydraulic circuit, and this is a relay circuit, or you can also say electrical circuit. Simply call it as electrical circuit. Yeah, that's fine. So we'll go to the simulation, go to the start button here, and what is the pressure? It is 502 psi. It is in psi, but I want it in pressure in bar, so double click on the pressure gauge, and unit should be in bar. Enter. So when you go to the simulation, so it is showing 34.6 bar. So I can adjust it here in the pressure relief valve. Maximum pressure I wanted in bar, so 29 bar is there. Okay, maximum pressure load is, this is the opening bar, opening pressure. Okay, yeah, it is changing here. Okay, you can set it to 50 here. One minute. It's changing. 60 bar pressure is there. See, now once S1 is operated continuously, cylinder is extended. So it's not, see, you can observe here continuously solid Y1 is on. So that means by operation of S1 switch once, cylinder is continuously working on the load, maybe for example closing the door or pushing the load. Once work is completed, so how can I retract the cylinder? I can operate the switch S2. Yes, it is retracted. So this is a signal storage. So storage means once S1 is operated, you don't have to operate the switch S1 continuously. Once it is operated, that is enough. And then by operating switch S2 only, it is going to retract. So S1 is set instruction, so the data will be continuously set, stored in the K1 relay box, and then when S2 is on, so it is erasing the data of S1 data. S1 is like a on signal, so that data can be stored and can be erased using S2. So this is the now working. And again, in the last video I've shown how to submit the assignment, right? So again, you can copy this circuits and to the Word file, and you can submit it. Okay. If you have any questions, you can put it in the comment section. I can address that questions. Thank you everyone. If you like this video, please subscribe to my channel to get more updates. Thank you.